So the first question is you have to be able to draw the force untuk electrostatic force untuk a charge. Okay? So firstly, kita tengok. Oh, actually, I'm gonna do from the lecture notes. This one. Okay, so firstly, untuk the exercise number 1, you have to be able to draw the direction of the electric force. So untuk setiap soalan, you have to be able untuk draw dia punya direction lah. Okay, so without the direction, you will lose marks ataupun you cannot exactly determine the direction. Okay? So first one, kita tengok dulu untuk yang ini. Okay, so we are going to draw the electric force acting on charge 1. Okay, so untuk charge 1, sekarang ni dia positive. Okay, so for a positive and negative, so this is an attractive force. Okay, so firstly kamu boleh lah dulu lukis dia attractive force. Okay, tapi sekarang ni kita fokus untuk what is being experienced by charge 1. Okay, so kita padam. Ito, sorry. Untuk charge 1. Okay, so kita fokus untuk charge 1 sahaja. Yang ini jangan kamu lukis. Dia punya draw the force tu jangan. Arrow dia tu. Okay, sekarang ni kita perlu determine pula force by 2 on 1. Okay, dia sentiasa force by 2 on 1. Jangan kamu, I mean boleh je pun actually on and by, tapi kita for us we use by charge, sekarang by charge 2 on charge 1. Okay, boleh faham yang itu? Okay, sekarang kita lukis pula untuk yang ini. Sekarang dia ni positive and positive. So this is unlike charge, so they will be pointing away from each other. Okay, so kita lukis untuk Q1 saja, padamlah untuk yang Q2. So this one will be force by 2 on 1 juga. Okay, boleh faham yang itu?
Boleh, Miss.
Okay, nice. Lepas tu kita lukis untuk yang ini pula. So this one is now is a negative charge. Kita tengok yang ini dulu. Okay, Q1 and Q2. So again, this is a like charge, so they will be pointing away from each other. Okay, so garisan arrow dia di sini. Okay, and then we look at Q4 here. So this is negative and this is positive. So they will have an attractive force. Okay? So arrow dia akan jadi pointing towards Q4. Okay? And then untuk Q1 and Q3 pula, this is a negative, this is a positive. So again, they will be attracted to each other. So the arrow will be pointing towards Q3. Okay, so tulislah force by 2 on 1, force by 4 on 1, force by 3 on 1. Okay, nanti dalam exam kamu lukis yang ini saja. Okay, right, now this one pula, Q1 is positive, so we will be looking at this one and then at this one. Okay, so this is unlike charge, so there will be an attractive force. So this is gonna point towards Q2, and then this one would also point towards Q3. Okay, so this is force by 2 on 1. This is force by 3 on 1. Okay, and then this one pula sama juga, unlike charge, so they will be pointing towards the negative charge. Okay, so this is force by 3 on 1, force 2 on 1. Okay, And then this one, all of these are like charge, so they will be pointing away from each other. Okay, so this is gonna be pointing here. This is gonna be pointing here. Okay, so this is false by 2 on 1, false by 3 on 1. Okay, so semua dapat betul ka yang ini? This is the most basic untuk chapter 1. You should be able to draw this. Okay?
Dapat, Miss.
Okay. Now let's look at question 2. So this figure shows a 3-point charges. So there's positive, negative, and negative charge. We have to calculate the magnitude and direction of the electrostatic force on charge 2. Okay, so charge 2 is this one here. So firstly, we are going to draw the direction of the electrostatic force. Okay, that's the first step untuk kamu solve the question. Okay, so let's draw that. Apply what we've learned before. So Q2, this is positive, this is negative. There will be an attractive force. So the arrow is going to be pointing towards Q1. Same thing applies to Q3. So this is force by 1 on 2. Okay, and then this one is force by 3 on 2. Okay, so you've done that. Now we have to calculate the magnitude of F12 and F32. Okay, the first step is draw the direction of the force. Next, baru kamu calculate the magnitude of this electrostatic force. So Q1, Q2 over R12 square. Okay, so R12 based on this diagram here is this one here. Okay, so R12 is equal to 20 centimeter. This one's gonna be R32. Okay? Okay, so ini kamu kira sendiri, you should get 54 Newton. And then this one, Q3, Q2, R32 square should equal to 125 Newton. Okay? So after you calculate the magnitude of these two forces, you have to resolve them into x and y components. So why do we need to resolve it into x and y components is because there is an angle here, okay? So it is not directly on the x-axis. It has the x and y axis. Okay, that's why you have to resolve them. So let's do for the x component. So F12x component is equal to F12 sine 17 degree. Okay? So why is it sine is because the angle 17 degree ni is not on the x-axis here. Okay? If the 17 degree is on the x-axis, which is this one, we will use cos. Okay? Boleh faham ah? So for that one, you should get 158 Newton. Is it 150? No, sorry, 15.8. 15.8 Newton. Lepas tu F32 untuk X component dia is just the F32, which is equal to 125 Newton. Okay? So in total, therefore, the force in the x component is just the addition of these two values. Okay, so you should get 140.8 Newton. Okay, so untuk y component pula, F12y is F12 cos 17 degree. So this one you should get 51.6 Newton. And then F32 untuk y component there is equal to 0. because this is just on the x component. Okay, so in total, the Fy is just equal to 51.6 Newton. Okay, after you calculate the x and y component, you have to find the magnitude. Okay, so the magnitude, we just use this one. Okay, you should then get the value of apa, 150 Newton. Okay, and then it doesn't end there, you still have to find the direction. So the direction is equal to shift tangent Fy over Fx. So you should get around 20.1 degree. Okay? Boleh ah? So that is the complete solution for exercise 1 number 2. Okay, jadi kamu punya steps, if kamu punya PSPM nanti subjective questions, should be similar to how I solve it. Okay? I think this would be around 6 marks. Macam tu lah. Okay? Boleh? Boleh continue?
Boleh, Miss. Boleh, Miss.
Okay. Kalau kamu mau tengok, oh, I'll upload the PDF version later.
Okay, Miss, thank you.
Okay. Okay, this one, exercise 1.2. Okay, so this one is on electric field, okay? So the first thing you need to know for electric field, untuk negative charge, when there's a point here, if kamu mau lukis electric field untuk negative charge, it will go into the charge. Okay, ni untuk bila dia punya charge here is negative. Okay, the second one untuk positive, bila ada satu point di sini, kalau kamu mau lukis for positive charge, it will go away from the charge. Okay? So, itu yang kamu perlu tahu untuk cara lukis electric field. Okay? Okay. Now, let's do this one. So, first thing, we are going to draw the direction of the electric field untuk point M here. Okay? So, this is a positive charge. So, we will be drawing the electric field to the right because it is going away from the positive charge. Okay? And then, untuk negative charge, the electric field will be pointing towards the negative charge. Okay, so this is your electric field for charge 2. This is for charge 1. Okay. So after drawing that, we have to determine firstly the length for charge 1 to point M here. Okay, so if we were to draw that, the triangle, remember, I don't actually remember the term, but if you remember 3 and 4, the hypotenuse will be equal to 5. Masih ingat kah?
Pythagoras.
Okay, Pythagoras theorem. So this one, 3, 4, 5. Ingat kah? Boleh ingat kan? Usually it comes with 8, 6, 10 juga kalau tidak silap. Okay, kamu ingat je lah. Kalau tidak ingat, kamu just calculate using the Pythagoras theorem lah. Okay? And then, since this is in both x and y component, we need to know the angle here. Okay? So, the angle, kita boleh calculate guna sine rule. Okay? You remember sine rule? Sine rule is sine theta over the opposite length, which is 3, and then sine this angle here, 90 degree, over the hypotenuse here, which is equal to 5. Okay, so the angle is equal to 36.7 degree.
Miss, kalau guna tangent punya, then
Pun
times
boleh.
3 over 4. Okay, Miss.
Yeah, you can either use sine rule ataupun itulah. Okay, after that baru kita boleh start to solve the question lah. Okay, so the first thing we will be doing is calculate the magnitude of E1, which is equal to K Q1 over R1. Okay. So R1 is equal to 5 centimeter lah. Then R2 is equal to 4 centimeter. Okay. So dari sini just substitute and then, oh I forgot square. Calculate them, you should get 7.2 times 10 to the power of 3 Newton per coulomb. Okay, make sure you are able to write the unit because without unit you will not have the marks lah. Okay, so E2 pula KQ2 over R2 square will be equal to 18 times 10 to the power of 3 Newton per coulomb. Okay, if you want to use the formula which uses this, ada satu formula yang equal to Q over 4 pi epsilon naught R square. Ada satu formula lagi yang macam ni kan? But I would prefer to use this one because it is much more simpler. Okay, but you can also use this formula. Okay, and then after finding the magnitude, we have to resolve it into x and y component. Okay, firstly for the x component, E1x is equal to negative E1 cos theta. Okay, why is it negative? Because when you are resolving this E1 into the x component here, it will be pointing to the left. Okay, so that's why it is negative. So this one's gonna be equal to negative 5.77 times 10 to the power of 3 Newton per coulomb. Okay, and then E2x is basically equal to E2, which is equal to 18 times 10 to the power of 3 Newton per coulomb. Okay, do the same thing for the y component. So this is E1y. This pointing up when you're going to resolve it. So it is positive E1 sine theta, which is equal to 4.3 times 10 to the power of 3 Newton per coulomb. Okay, untuk electric field for charge 2 will be equal to 0 because there is no y component. Okay, right. Now, after doing that, we have to calculate the, Ex, the electric field for the x component, which is basically the addition of these two values. So you should get around 12.2 kilonewton per coulomb. Then for this one is equal to 4.3 lah, kilonewton per coulomb. Okay, after that baru kita calculate the magnitude. So Ex square, Ey square, which is equal to 12.9 kilo Newton per coulomb. Okay, so the direction, do the same thing, shift tangent, Ey over Ex, which is equal to 19.4 degree. Okay, so that is the solution for exercise 1.2 lah. Okay, make sure the steps kamu familiar lah, okay? Because it is basically using the formula. Okay, Bullet scan. Okay, Kak, boleh continue.
Boleh,
Kamu punya
Miss. Boleh, Miss.
Okay. Okay. So this one is actually exercise 1.3. Hilap tulis. Okay. So I'm gonna do this. The page. So this is the positive. Yeah. Then we have okay, so this is point S, this is point T. So now this is on electric potential. Okay, so for electric potential, aduh toto, sorry. Okay, for electric potential, what you need to know is untuk sign dia, kamu mesti include. Okay, so if it is a negatively charged, untuk the Q, you have to substitute the negative juga. Okay, right, so the first question is asking us to calculate the electric potential between point S and T. So maksudnya between point S and T is basically asking us about the delta V. Okay. So this is kejap 8 centimeter. This is 8 centimeter. This is 6 centimeter. Okay. And this charge here, kejap. This is positive 5.4 nanocoulomb. Okay, so it is asking us to calculate the electric potential between point S and point T. So that is Vs minus Vt. Okay, so firstly, what we will be doing is write the formula aja lah. Okay, so V is equal to KQ over R. So that is the formula for electric potential. Okay, now what do we have? We have RS. However, we do not have RT, which is this one. So RT is again the hypotenuse of this triangle. So this is equal to 10 centimeter. Okay, remember 8, 6, 8, 6, 10. Okay, kalau udah hafal, kamu kira lah guna Pythagoras theorem. Okay, so let's do this. Vs is kq over rs minus kq over rt. Okay, so calculate that. You should then get the value of this one is 810 minus 486. You should get 324 volt. Okay? Okay. And then question B pula. Let's recalculate the work done in bringing a charge from point T to point S. Okay? Remember the work done is calculated using Q delta V. Okay? So basically Q is the one yang tadi itulah kena bagi, which is 1.5 nanocoulomb. Delta V is the one up here, which is equal to 324. Okay, calculate that. You should get 4.86 times 10 negative 7 joule. Okay? Boleh faham untuk exercise 1.3?
Boleh, Miss.
Boleh, Miss.
Okay.
Miss.
Okay, last. After this quiz. Okay, exercise 1.4. Okay, so now there is two parallel plates separated 5 millimeter apart. So for example, this is your parallel plates. Okay, so it is separated by 5 millimeter. 5 millimeter. Okay, so the electric field between the plates. So remember, for a parallel plate, the electric field will be uniform, just something like this. Okay, so the electric field given is 1 times 10 to the power 4 Newton per coulomb. So there is a small charge of positive 4 nanocoulomb move from one conducting plate to another. So now we have to calculate the work done on the charge. So work done is equal to, ini untuk uniform electric field. So remember, for parallel plates, the electric field will be uniform, okay? So we can use the formula F, work done equal to force times dengan the separation, okay? So remember, force pula equal to QE, okay? This is for uniform electric field job, okay? So from here, just substitute lah. So you should get 2 times 10 negative 7 joule. Okay, now the potential difference pula, we can then use work equal to Q delta V. Okay, so they ask about the potential difference. So work over Q equal to 50 volt. Okay, so that is the solution for exercise 1.4. Okay ka?
Okay, Miss.
Okay,
Miss.
Miss mau cari apa? Azlinism. Kada muat. Kamu kenal ka din eh? Azlinism.
Ya,
Siapa yang
Miss.
kenal dia? Oh, ada pula kau. Lambat juga kau masuk kelas. Dah, Miss mau tanya, kenapa dia antar kuis? Si
Quiz.
Redzwan pun. Wih, tak menjawab.
Miss,
Kenapa?
actually masa day of submission, I changed room 2 times, so I was very tired that day, and I'm very sorry I didn't inform you about it.
Okay, next time antara.
Alright,
KML sudah kau?
yeah, Miss.
Okay. Okay. Quiz lagi ya. Kamu mau rehat nih 5 menit.
Mana-mana aja, Miss.
Jangan Miss makan kerupuk.
Oke, Miss.
Miss, ada soalan.
Apa soalnya?
Soalan kedua paling last. Yang work done tu.
Oh, ni. Ni.
Tak, sebelum ni.
Oh, 1.3.
Sebelum ni.
Oh, ni. Kenapa?
Ya ini. Yang charge tu Miss, tak payah taruh sign dia kah?
Untuk work done dia
Sebab
payah.
charge dia di sini negatif 1.5.
Untuk work done sepatutnya dia payah.
Yang B itu.
Ni kan work done. Dia payah, Miss pun lupa. Kita cek dulu nota. Sepatutnya dia payah. Sebab untuk electric potential saja yang perlu.
Oh, okay Miss.
Ya, work done dia payah tu. Untuk electric potential, ya kita
Ya,
perlu
Miss.
masukkan dia punya charge. Boleh faham kan?
Okay Miss. Thank you Miss.
Jawab kan soalan, mana tahu saya bingung-bingung, salah-salah jawaban. Untuk ini je, kita letak sign. So if di sini ni dia jadi negative 5.4, sini pun kita akan letak negative 5.4 lah. Okay. Okay ke tu? Okay. Itu job quiz lah. So untuk quiz, yang soalan objective questions tu, it actually prepares you for the UPS lah. UPS kamu, actually saya pun lupa bila. UPS kamu sepatutnya hey, what happened? Ini ada perubahan sudah. Cepat Miss check dulu bila UPS kamu. So your first UPS, chapter 1, 2, 3 will be on 14 February. Week yang 14 February. Valentine's Day punya week. Okay, boleh? Itu je lah. Quiz. UPS. Right, so let's do the quiz punya questions. So the first one, jawapan dia is attractive force. Jawapan dia A. Ini kamu perlu explanation kah? Tidak kan? Question 2 pula jawapan dia A. It remains almost exactly the same. So for uniform electric field untuk parallel plates, it is independent of the charge. It is only dependent on the charge. So formula yang kita guna sepatutnya sigma over epsilon naught, but this one is not in your notes, where sigma here is the charge density. Okay, so for this case untuk parallel plate macam ni, Okay, so parallel plates macam ni, the electric field is not affected by the separation nila. Okay, it is only affected by the charge. The charge density. Yang penting that remains almost exactly the same. And then question 3, jawapan dia B3W. How do I do that? Is first work is equal to Q delta V. Then the second situation, the charge is increased to 3Q, so delta V. So this one here is W, so 3W. Okay? Okay, two objective questions. Now let's go to the subjective questions. Okay? So the first one, so we know that Q1 is equal to negative 86 microfarad, Q2 is equal to positive 50 microfarad, and then Q3 is equal to positive 65 microfarad. Okay, so the drawing is a triangle, and then we have the church, and then this one is church as well. Q1, Q2, Q3. Okay, so this is Q1, Q2, Q3. Okay, so this is 52 centimeter. This is 30 centimeter. Yeah, for this one is R13. So we have to calculate it. So this one is gonna be 30 square, 52 square equal to 60 centimeter. Okay, so now this will kita tengok on charge number 3, which is this one here. Okay, so that one we will be just look. So Q2 is a positive charge, Q3 is a positive charge, Q1 is a negative charge. Okay, so sekarang baru senang sikit melukis. So for Q3 and Q2, this is like charge, so it will be pointing away from each other. So this is for Q2, and then untuk this one, this is positive and this is negative, so they will be having an attractive force. So it's gonna be something like this. Okay, so this is force by 2 on 3, force by 1 on 3. Okay, so sekarang pun dia ada X and Y component. Okay, so we have to know the angle here. Okay, we have to know, it's given, it's 30 degree. Okay, so this is 30 degree. Okay. Okay, now kita boleh calculate the magnitude of the charge. So F23 is K Q2 Q3 over R23 square. Okay, so dari sini just calculate that. You should get 139.75 Newton. Lepas tu F13 K Q1 Q3 over R13 square equal to 325 Newton. Okay, so do X component, and then X component for F23X is equal to 0, and then F13X is equal. So F13 cos 30 degree should get 121 Newton. Okay, and then for Y component, F23Y is equal to F23, which is equal to 139.75 Newton. And then F13Y is equal to negative F13 sine 30 degree, which is equal to negative 69.9 Newton. Okay, and then have to calculate lah untuk Fx dapat berapa? Fx is 121 Newton. Fy is the addition of this lah. Okay. Then you should get 255 Newton. Okay. Lepas tu bolehlah calculate the magnitude Fx square plus Fy square, which is equal to 282 Newton. Lepas tu angle shift tangent Fy over Fx equal to 64.6 degree. Okay. Boleh kan? Simple je soalan dia. Dapat jawab
Boleh.
SPM maksud dia. Okay, good. So question 2 pula is on electric field. Okay. So this one's gonna be this point, and then 2, 8. So this is so this is R1, which is equal to 2 centimeter, R2 8 centimeter. So this is point P, this is Q1, this is Q2, where Q1 is equal to negative 25 microcoulomb, Q2 is equal to positive 50 microcoulomb. Okay. So from here, we have to draw the electric field dulu. Okay. So remember, untuk negative charge, it will be pointing towards the charge. Okay. And then for positive charge, it will be pointing away from the charge. So both will be pointing to the left. Okay. So this is E1, E2. Okay. So itu dia punya the drawing of the vector. So E1 is equal to K Q1 over R1 square. So you should get, since it is pointing to the left, it will be negative. So negative 562.5 times 10 to the power of 6 Newton per coulomb. Okay, and then E2 pun sama, it is pointing to the left. So it will be negative. So it should get negative 70.3 times 10 to the power of 6 Newton per coulomb. Okay, so sekarang ni dia ada X and Y component. I mean dia ada Y component, so it lies on the X axis. So we can just directly add them together lah. So E1 plus E2. Make sure to consider the negative, the direction, because this is a vector. So you should get negative 632.8 mega nano per coulomb. Okay? Okay. Itu je. Yeah. Oh, the direction? Direction is to the left. Okay. Why is it to the left? Is because there is a negative sign there. Okay. Now question B. Question B. Dia minta apa semua? Oh, dia minta the acceleration. Okay, untuk electron. So mass of an electron is equal to 9.11 times 10 negative 31 kilogram. And then the charge for an electron is equal to 1.6 times 10 negative 19 coulomb. Okay, remember the formula A equal to E over M. So kita guna that form. Sorry, we are gonna use this formula untuk calculate the acceleration lah. So substitute all the values. then you should get 111.14 times 10 to the power of 18 meter per second square. Okay? Okay. Itu solution untuk number 2. Okay, number 3 pula. This is on electric potential. So R is 0.5 meter. If it is positive and negative charge, this is basically just to test whether you remember that we need to include the sign untuk electric potential. Untuk electric potential saja. Okay, so V is equal to KQ over R. So this will be 360 kilovolt. Untuk Q yang negative 50 microcoulomb, do the same thing except you have to add the negative, which is equal to negative 360 kilovolt. Okay. The negative here ni maksudnya the negative dari the charge, ha? Jangan kamu letak negatif di sini, and then kamu letak negatif lagi di sini. Dia jadi positif. Okay? Okay, last question. Number 4. It asks about the work done. Okay, so Q given is 3 microcoulomb, and then the first distance is from infinity. So for infinity, remember it will equal to 0. Okay, so R2 pula, it is equal to 0.5 meter. Okay, dia cakap dari infinity to this distance. So the charge here is equal to 20 microcoulomb. Okay, untuk yang ini kita akan guna work equal to Q delta V. Okay, so Q here will be the one yang 3 microcoulomb. So delta V is basically KQ yang besar tu R2 minus KQ over R1, where the one here will be equal to 0. Sebab R1 ni at infinity, so dia akan equal to 0. Okay, so you should get the value of 1.08 joule as the answer. Okay, boleh? Habis sudah. Boleh so kamu sambung tidur. Okay, ada soalan?
Tiada, Miss.
Okay, ngam.